Hello, hello, physics. Alright, this is going to be your tilted video, where I'm going to walk you through the how to solve the tilted problems. Now, it doesn't change the way you solve the problem at all. All tilting the problem does is change the way you start the problem. So it changes your free body diagram, and it changes your axis. So I'm going to be using the last homework problem as an example, and I'm forgetting what number that is, 15. And I'm going to be showing you how to set this problem up. This is not the only tilted problem in the homework, and there will be one tilted problem on your test. Okay, so you need to make sure that you know how to do these. So, and bear with me, this is my first time ever recording in my apartment. So I've got this little board, and I'm trying to make everything fit. So in problem 15, there is a crate sitting on a ramp to a concrete dock, and it tells us that there's a force being applied perpendicular to the surface of contact, and it wants us to calculate the magnitude of that force. It tells us that there is a frictional force. It tells us the mass of the crate, and it tells us this angle theta along with the coefficient of friction. So what force Fa must be applied in order to keep the crate from moving? So first off, we're going to draw a free body diagram, just like we normally would. Now, I'm going to do that over here. We have our applied force this way. We're going to have a normal force that is perpendicular to the surface of contact. The crate is trying to slide down the ramp, which means there is a frictional force up the ramp. And there is one more force. And if a tilted problem is set up correctly, this is the only force that you actually have to break up into components. Because no matter what, weight is always straight down. It is never going to be at an angle. It is always going to be straight down. Now, here is the beauty of setting up a tilted problem. What we do in a tilted problem is we tilt our axis so that positive y, positive x, negative y, and negative x are in the same setup, but this way our forces are acting perfectly along these coordinates, except for the weight. Now, you solve this just like you normally would. You just have to break up your weight into its components. What that looks like, or then this is the part where people get stuck. They always try to put the angle, the theta angle, in the wrong spot. So I'm going to tell you that this angle is the angle between the normal negative y and the new negative y. Now, normal negative y is where your weight is, straight down. The new negative y is going to be along the orientation that is the current bottom. Okay? So in this case, FA is acting in negative y. So then the angle between FA and FG is theta. And this has to be the vertical axis. So if this is FG, and this is negative y, then this has to be negative x. So makes this our right angle. Theta, FGY, and FGX. And then you just write sum of forces equations from that. So x would be opposite, y would be adjacent. You use your trig functions, you get your sum of forces, and then from there you solve it just like any normal problem would go. This is the sticking point. This is the key. It's the tilted coordinate plane. Okay, that's all there is for this. It's Tuesday, so this should go up, and you guys should have plenty of time to let me know if you're having trouble with any of this. Send me an email if something isn't making sense. I want to have the opportunity to get you guys help on this if it doesn't make sense. Don't wait, because you have a test in a week, not a test, a quiz in a week on Tuesday next week, where we're going to be going through this. And this, you're going to have 1 or 2 tilted problems that you're going to have to solve. So, get a hold of me. Don't wait till the last minute on this. Get a hold of me now if it's not making sense, and let me know. This is the last video. Unless you guys need more help, this is the last video for this chapter. We have a test not this Friday, but next Friday. And we need to talk about that at some point, how we want to set that up. I'm inclined to post it at 7 in the morning on Friday and give you until 7 in the morning on Saturday, since you have the school day to work on. But if that is not going to work, then you need to email me and let me know if you need another option for that. I haven't started looking at the next unit yet. I'm trying to decide still if that's going to be Chapter 5 and Chapter 6 or just Chapter 5. I'm not sure we have enough time to get through 5 and 6 before Christmas, but I know that we have way more time than required to get through just Chapter 5, because there are no labs in Chapter 5. So that's kind of my conundrum right now. I am not going to force you guys to take a final over 5 and 6 the last day of the semester if we are not ready for it yet. So don't stress too much about that. We can always finish up the unit when we come back. So, like I said, let me know, and we will see what we can do. So, have a wonderful night, and I'll look forward to hearing from you guys in the next day or two. Don't forget about your lab report. Your 4.1 lab report is also due on Thursday, 2 days from now, so get that done too. And that's it. Have a good... I missed the button, so now I'm going to stare awkwardly at the screen for a second. Let's try that again. Have a good one.